What's up, everybody? Welcome to CSTV Cribs. We got a lot of stuff going on today, mostly Capstone. So why don't you come with me? Let's take a look, see what's happening. Right in here, it's a big man. What's up, Dr. Kazim? Want to tell us a little bit about what's going on with the project?
So I would like you to develop a brain computer interface application that a person is going to wear an EEG device, and then he is going to play a game using only his thoughts. He's going to imagine an agent in a game to move left or right, then agent on the game supposed to move left or right. So that's going to be a simple task in terms of agent movement, but you are not going to use keyboard or mouse, nothing except your thoughts.
Excellent. So that's what we got going on today. So if you come right this way, you'll see what we're actually doing to make this little vision a reality. Gentlemen, what we got going on in here? I see we got a lovely Jacob Bowen hooked up to this EEG device. As you can see, what we have going on here is some major science. See, each one of these is an electrode that's measuring the microvolts of electricity that come through the skull from brain activity. These read them and tell us how much activity there is in each spot on the skull. As you can see over here, we have a visual representation of that data. Not a lot of activity, but that's okay. Now, we also have our own program that's able to read the data from each of these electrodes. There's an array of 32 different numbers that correspond to each of the readings, and with that, we'll be able to do some wicked science. Now that we've not seen what's not going on in Jacob's brain, let's go see what's going on down here. Hey, yo!
Oh. So we have a lot of data collected at this point, and thankfully we actually collected our data in a manner where we had people read prompts from a screen and then reflect those actions as we took their EEG data. So we hope to create a neural network that'll map those functions onto the data we collected to hopefully read those functions into something else. Like I said, we're going to do that via a neural network. We're not too sure the specifics of what we're going to do right now, but that's where we're at.
Thanks for the information, bro, man. Now, as you've seen, we got some cool brain science going on. But we got more than that, you know. We got games.
So now that we've actually done with a neural network, we're going to feed this data to a game. I call it dodge call. The point of the game is to dodge cars, obviously. The player can either stay in the center by doing nothing, or can squeeze their left fist to move left, squeeze their right fist to move right. Who's that?
I don't know. Why don't we go find out?
Not welcome here. This door's been unlocked the whole time? Well guys, we still have a lot to do with the project. We still have to create our model, and we have to use the neural network to train it, get our machine learning and our AI down. And we're gonna use the data that we've collected from the EEG, and we're gonna implement this into our game so that your brain can essentially control the binary game that we have made. Currently, we have just our binary game that we need to do a little bit more work on, and we have a snake game. And at the end of it, we're hoping to have it integrated with our EEG so you can play games with your brain.
Thanks, Jacob. Now, let's go on and see what we can do. Oh!
What do we just watch? I'm gonna use an iWatch station.
I hope.